Okay, so in this video, we're going to look at how to solve problems with the normal distribution. I've just got one example for us. It's got parts A through to E, but it's going to show us how to calculate a simple probability, to calculate the mean of a distribution or a standard deviation of a distribution, and then how often questions can turn from being a normal distribution into a binomial distribution or something else. So let's see how it all works. We get the Covid Confectionery Company markets chocolates in 750-gram bags. The weights of the bags are normally distributed with a mean of 756 and a variance of 100. Okay, so we know that we're dealing with weights being normally distributed with 756 and 10 squared. Now that is mu and that is sigma squared in there. Find the probability correct to 4 decimal places. A randomly selected bag will weigh less than 750. So that's probability of W being less than 750. Now remember, we can do this with our calculator. We do not have to integrate this one. All we need to do is go to our calculator. We're going to go menu, 5, distributions, normal CDF, and have our value. So lower bound is less than, so it's negative infinity. 750 is upper bound. Our mean was 756 and our standard deviation was 10. We combine all those together and we end up with this value of 0.2743. And that is the probability of getting less than 750 grams with this mean and variance. Part B. The CPA receives a number of complaints and is about to investigate. The company will be fined heavily if too many bags weigh less than 750. They don't want to do that. So the packaging process is changed to make sure that 95% of the bags weigh at least 750. At the moment, they've said 750-gram bags, but only 27% are less than, so only 73% of the bags they make, 3/4 of the bags they make are that big or bigger, which is not really good enough. So now they're going to change it to make sure the number less than is only 0.05. So we're going to find the new mean weight if the variance is staying the same. So now we're dealing with the weight is normally distributed. We don't know the mean, but we still know the variance. Now the information we're told is that the probability of being less than 750 needs to be 0.05 because we've been asked to find, so the probability of being bigger than 750 is 95%. Which means less than 750 must be 5%. So we're going to deal with this. Less than 750 is 0.05. Now let's think of this in terms of bell curves. The bell curve here. We've got some mean, but we don't know what the mean is here. And we're trying to find a probability so that if I put 750 there, this shaded area here is equal to 0.05, meaning all this large area here is 0.95. Now we are not able to find the value for mu. We can't undo it using this distribution, but we do know that I can, over the top of that, lay a Z curve, standard normal curve, where the mean we know is 0 and standard deviation is 1. And there's going to be an equivalent position here, I'm going to call it C in this case, such that the variable is C, that if I have Z being less than C, that will be 0.05. So if I can find the value for C, I can then use our conversion between our standard normal and the normal distribution we have to find mu. So let's do that. We know I can put this in the calculator. And we're going to do it with using inverse normal this time. We've been given a probability. We need to find the variable. Now, area is always to the left, which is why I looked it to the left. 0.05, 0 and 1 is what you have for Z, and you end up with negative 1.64485. And I'll drop the negative, but there we go. That's the value we're looking for then. Remembering, of course, Z is normally distributed with 0 and 1. Once you have that, we substitute it over here. This value of C is our Z score, so we get negative 1.64485. It's good idea to hold all the decimal places to the end. So this is slightly rounded. We'll select the use answer option in a minute on a calculator. This value of X is the value they gave us, which is 750 grams. Mu is what we're trying to find, and standard deviation we know is 10, because the variance was 100, square root is your standard deviation. Now, to solve for that, you're going to multiply by 10, and then we're going to do 750 minus that answer. And you get 766.4 grams, because it asks you to one decimal place. So that will be the new mean, is what we're asked for, to make sure that at least 90, that the 0.95 chance, 95% chance of weighing at least 750, I should say. All right, next one. What standard deviation correct to one decimal place would be acceptable if the mean weight is to remain? So this time we're looking at normally distributed weight. The mean is still 756, but I don't know standard deviation. I'm going to do the same thing. This whole section here is exactly the same. There's nothing different with any of that. What is different though is the final, the final equation over here, the z equals x minus mu over sigma, is no longer trying to find the value of mu. We are instead trying to find the value of sigma. So we're going to substitute the known values in, 750, we know mu this time, and divide by sigma. So if you do all that, you'll end up with sigma being 750 minus 756. In the denominator, we're going to bring down our 1.64 into there. It's not going to work for me, of course. Sometimes it works, sometimes it doesn't. Okay, it's not going to do it for me. Negative 1.6. Give you 3.6 grams for your standard deviation. Part D, which alternative is preferable from the company's point of view, and give a reason? Well, which one is preferable? Let's have a look at each one. So remember, when you're doing each one, we're going to have a bell curve. So I'm going to draw in, let's do it in darker, let's do it in black. We're going to do where the weight is normally distributed with a mean of 766.4 and a variance of 10 squared. That was the one up the top there. So let's draw that. And that's going to be something like that there, where that is 766.4. And on the same graph, I'm going to now draw one with 756 being the mean and 3.6 being the standard deviation. Well, 756 is going to be about there-ish. And notice the standard deviation, so I should put the variance in here, 3.6 squared. The standard deviation is much less, which means the graph is squished. So it's going to start from a lower position, and it's going to go higher into a higher position, and then go, whoops, that's a terrible effort. Let's try that again. Enough again, let's try one more time. That's better. Something like that, a bell curve. So what's happening is the graph, the tails of the graph are a lot lower. The middle of the graph is much higher because the standard deviation is decreased. What it means is more of the values are close to the mean. Okay, so there's my mean, but more of the values are sitting in here, nice and close to the mean. Whereas for the black version, you have more that are spread away from the mean. So which is better for the company? I'm going to suggest the yellow one is better for the company. Now it's better because look at the mean. The mean is much smaller, which means the average number you're going to do is smaller, which number one for the company is good because it's going to have less products going out. So less packages are going to be bigger than 756, because remember above the mean is 50%. So with this one, 50% of them are going to be bigger than 766. Whereas only with this one, it's 50% is bigger than 756. So this one's going to cost them a whole lot more. And in terms of spread, it's going to be more consistent. So much smaller value means more consistent for the company and for its purchases. So the yellow one is better for those reasons. Last one, the company decides to alter their process. The bags have a mean weight of 760. So we've got it normally distributed. We've noticed it's been normally distributed the whole way through. So mean of 760, variance of 50. Remember that is sigma squared. And then these bags are packed for distribution to the retailer in boxes of 25. And 25 bags in each box, sorry. 5 bags are randomly selected from a box for checking. What is the probability that 3 or more will weigh less than 750 grams? Now, this is no longer dealing with a normal distribution. That should be given away because we've got 5 bags are being selected. Now, that's an amount being selected at random. We were not dealing with a discrete countable amount before. We were not dealing with how many. We were dealing with how much in a measurement sense. So it's different. We've moved away from probability. And hopefully you can see it's binomial. And we can say X is binomially distributed. N is this 5. And P we don't know. The probability of success will be the probability of selecting. This thing here is going to be the probability of a bag weighing less than 750. So see how we're mixing the amount with now the probability of a weight. So it's mixing between the two. So to calculate this one is the probability of X being bigger than or equal to 3. That's what 3 or more means. So we're trying to find this, which means the probability of X being 3, 4, and 5. And they're whole numbers. And this is binomial because selected at random, you're going to have the probability of each one is going to be the same, not going to be changing. And we're going to have 2 options. It's less than or greater than. And there's not a specific order, so it's binomial in this case. So we need to find this thing first, and then we can use our binomial theorem. So we do use normal to start with. So remember to find the normal value, the probability of W being less than 750 is going to be equal to, well, we use our calculator. We're going to have our menu 5, 5, and then number 2. The lower value is that one. The upper value we said was 750. The mean was 760. And the standard deviation was square root of 50. Like that. And we end up with a value of 0.07865. 0.07865. That's rounded value. Now, when I'm doing this next step, we need to remember that we have got a probability of success now as 0.07865. Oops. So I'm going to put this into my calculator. Now remember, to do this, we use binomial CDF on our calculator. So we're going to go back in here. We're going to use binomial CDF, which is menu 5, 5, and CDF is hanging down here as letter B. And in here, number of trials is 5. We want success probability was 0.07865 like that. Lower band is 3, upper band is 5, and you find 0.0043. So 0.0043 is the probability that I wanted. So it's a very, very low chance. That's only a 0.4% chance now of it being, of having 3 or more of these bags being selected being less than 750 grams. So hopefully you can see the way it turned from being a normal, calculating the probability of one thing happening, to being binomial, because now we're counting and pulling things out. And that is how we do some problem solving with the normal distribution.